This is Geometry Unit 6, Lesson 4 on side, side, side. So this time we're going to prove triangles congruent the third way. We've already done side, and angle, side, angle. This one is side, side, side. The side, side, side postulate is probably one of the easier ones because it's just telling you exactly what you have to find. Side, side, side means you have to find if all three sides of one triangle are congruent to the corresponding sides of a second triangle, then the triangles are congruent. So in other words, if we are given two triangles, ABC and A prime, B prime, C prime, where AB is congruent to A prime, B prime, BC is congruent to B prime, C prime, and CA is congruent to C prime, A prime. So these three sides that correspond are congruent. Now, we're actually going to use rigid motion to prove that this triangle will line up perfectly to this triangle given that rigid motion. So let's try it out. So let's do the same thing that we just did for the previous ones. All right, now again, we said that AB was congruent to A prime, B prime, C prime, or A prime, B prime. BC and BC prime are congruent, and AC prime and AC are congruent. So those three sides are congruent. So let's use translation along A prime A. It's the same thing we've been doing with the other ways, so let's try it with this. All right, so let me use my dotted line here with red, and here we're going to translate along A prime until we end up here. So that means this, and this are all still congruent. So this triangle becomes this triangle. So A prime becomes A. So that means that A prime lines up with A, and that's the first point that we know lines up with each other. They correspond. B prime becomes B double prime, and C prime becomes C double prime. So there's the three points of the triangle. So now we have proved that A coincides perfectly with A prime, or A prime coincides with A. Now, again, like we did with the previous ones, we're going to rotate clockwise around A. So we're going to take this triangle right here, and we're going to rotate it clockwise, like this, until ray AB prime, this ray right here, coincides with ray AB. So until this ends up over here. Okay, so, and remember that we know that AB prime, double prime, is going to be the same length as AB because we were given that A prime, B prime, and AB were prime. We're congruent. That's what we were given. So since AB is congruent to A prime, B prime, that means B double prime will be equal to B. So now we know that A corresponds to A, B corresponds to B. So there's the two points of the triangle. Now, we're going to add something else into this problem. We're going to add segment, line segment, C triple prime C. So basically we're going to connect this segment here. We're going to create a segment. And we're going to label the angles that are created there. So I'm going to call this angle 1, this angle 2, this is angle 3, and this is angle 4. So that created 4 angles. Now we're doing this for a reason. If AC is congruent to AC prime, so we know that this side was congruent to this side. Those two were congruent. That makes this right here an isosceles triangle. And what do you know about the sides of an isosceles triangle? Well, it has two sides equal, which means the two angles are equal. So angle 1 will be equal to angle 3. So this angle will equal this angle. Now, we also know that BC and BC prime are congruent. Those two sides are congruent because we were given that. So that means that this right here will be an isosceles triangle, and CB prime C, CBC double triple prime is an isosceles triangle, and that means that the base angles of that are congruent. Angle 2 is congruent to angle 4. So we now have triangle ABC triple prime and triangle ACB. If we take these two angles right here and add them, 2 and 4, add them to 1 and 3, that gives me that angle and that angle by addition are congruent. So that makes triangle ACB here congruent to triangle AC triple prime B right there. Those two triangles are congruent by side angle side. So that proves that if you have side, side, side and use side angle side, those two triangles are congruent. So we have just proved that triangles can be congruent by side, side, side. So now that we have done that, we can now prove that side, side, side proves two triangles congruent. And now we can use it in a proof. So if I want to use side, 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 you have to prove 3 pairs of corresponding sides are congruent. So you have to prove 1 pair of sides, another pair of sides, and a third pair of sides. And they have to be the corresponding sides. So I would have to prove AB is congruent to DE. That would be one side. BC would have to be congruent to EF. And AC would have to be congruent to DF. So, if these 3 sides are congruent that correspond, that means that triangle ABC is congruent to DEF by side, side, side. And that is side, side, side. That's why side, side, side works, and that's how you apply it. All right, tomorrow in class, we are going to actually do the proof of using a side, side, side. See if you can take a shot at it and see if you can get at least part of that. So if we take a look at it for a second, see if you can draw the triangle that you're going to need for this. Read the given and see if you can draw the triangle and figure out what it's supposed to look like. We'll do the proof together tomorrow in class.